So in this video we'll talk about the functions, so basics of function we will do, and some problems on function we will solve to understand how it is working. So we are familiar in our previous years how a function works, just a basic revision type of video. So let A and B be two non-empty sets. Okay, then a function which is also called mapping. A function is also called mapping. So a function f from A to B is a relation from A to B. Basically, it's a relation. Okay, so it should satisfy all the conditions for being a relation. So the function f from A to B is a relation from A to B such that for each element A there is a element B such that A comma B, the ordered pair, belongs to that function. Okay, so there is some A. If you apply that function, okay, so it should result in B, and there should be an ordered pair. Okay, so there should be an ordered pair in that set already. Okay, so we can represent a function as A comma B belongs to F. So we can also write like B equal to F of A, so as we have denoted here. Now there are some naming conventions for this. So element B is an image of element A, okay, which belongs to set A. We have given here element B is an image of element A. Element A is a pre-image of element B. So let's just like we will write a diagram here. So let's B apply the function. Okay, so apply the function f of A and you will get B here. Okay, so this will be the B will be the image, this will be the pre-image, this will be the pre-image. So this A, f of A, when we call it, so A is also called argument of function f. Okay, so A is also called argument of function f, and B is called value. So B is called value of function f for argument A. So B is the value of function f for argument A. So this different naming conventions we are talking about here. So so we'll just revise. So B will be image, where the two argument A is a pre-image. So another convention is if you have f of A, that A is called argument. So when you get B, so that will be called value. So the value for argument A. So these are some naming conventions we should know. So if you have a function from A to B, A is called the domain of F and B is called codomain of F. A is called a domain of F and B is called codomain of F. Next one, the subset B consisting of images of all elements of A under F is called a range of F and is denoted by F of A. So what basically means is set A contains some elements. Okay, so you apply function to the all the set, means for every element of set A you apply the function and populate it in some subset of B. So let's call it some J. Okay, so there are many elements in set A, so you apply function to each and every element of set A. So whatever result you get, you make a set out of it and name that set. Then that resulting set, okay, that resulting set is called range of F. Okay, so whatever value you are getting by applying the function to all the elements of the set A, so that result is range of f. Okay, so that's denoted by f of a, means you are applying function to every element of a. That's what it is signifying. Okay, so we'll do all the problems on this so that we understand it better. Okay, next one. So if some element a belongs to a comma b, and also a comma b1 and a comma b2 both belongs to function, then b1 equal to b2. What it is exactly saying is, in a function you cannot have two images. So suppose you have here one image b, c, so you cannot have something like this. Okay, so when you apply a function f of a, you get a unique value, so there should be a unique mapping. So in while calculating in equation, somehow we get something like a comma b1 belongs to so a comma b1 belongs to maps to a, so a and b2 maps to a. Somehow if we get that equation, then b1 should be equal to b2. Only then that kind of mapping is possible. Okay, that means they are basically same. So this is indirectly telling us that f of a will be having a unique image in set b. Okay, so if we get this kind of condition in any of the equation we are calculating, then b1 equal to b2 it will be, because a can have only one image possible. Okay, so multiple images not possible, multiple images not possible, two different images are not possible. So that's why, as two different images are not possible in the equation, while calculating or solving some problem, if we are encountering this kind of situation, means a b1 a b2, then b1 should be equal to b2. Okay, so because two images are not possible, b1 and b2 should be the same image. Okay, so this is about having a image and pre-image. But you should understand that so suppose some c you have, a and b you have. Okay, so two of the pre-images can have same image. This is possible. Okay, so two of the pre-images can have same image. This is possible. But this is not possible. Okay, so and it will have always a unique image. Next, an element b which belongs to set b need not have a pre-image in a under f. Okay, so what it is telling is, suppose there are three a b c. Okay, so here you have some e f g h something you have, and this mapping is like this. Okay, so h is which is not mapped to any pre-image, so that's okay, not a problem. Okay, so something no pre-image kind of element is there in set b, that's absolutely fine, still it belongs to function. Next one, a pre-image need not be unique, that's what we discussed here. Okay, so you can have a b c, so here pre-image is not unique. For C, pre-image is A, pre-image is B. That's fine. Okay, image should be always unique. Pre-image need not be unique. May be unique or not be. Both are fine. Okay. So that denoting like this, A comma B belongs to F. A F B. B equal to f of a are all represent same equivalent. They are all equivalent. Okay, they represent same meaning. Okay, so this is about some basics of function. Let's start with the first problem here. So we have been given a and b. So 1, 2 and 3. We have -1 and 0. So let the relation is defined. Let's map that one. Okay, 1 -1. 1 0, 2 -1 and 3 0. So is this relation a function, yes or no? So it is not a function, this is a relation, but it is not a function. Why? Because 1 is mapped to -1, 1 is mapped to 0. Uh, so one which belongs to set A does not have a unique image, does not have a unique image in B. Therefore this is not a function. Therefore uh, this R is not a function. R is not a function. Okay, so let's take a second problem. Let's see is it a function or not. So 1 2 3 minus 1 0. Let's map 1 to -1, 2 to -1, 3 to 0. So yes, this relation is a function. This relation is a function. Okay, so why this is a function? Because one maps to my, so all pre-image have unique images. Okay, all pre-image have unique images. Okay, so all pre-images have unique images. One map to -1, 2 map to -1, 3 map to 0. Okay, so we should also recall that image can have multiple pre-images. That is not so pre-images, sorry, images may have multiple pre-images. That's not a problem. Okay, still it is a function. Images may have multiple pre-images. Okay, so this is a function, so the mapping is fine. All are mapped. Okay, so 1 2 3 they are all mapped. Okay, so and also they are having single images in B, so that's fine. This is a function. Okay, so let A equal to 1 2 3 4 and determine whether or not the following relations on A are functions or not. Okay, so here the mapping is from A to A. So you have 1 2 3 4, 1 2 3 4 mapping is from A to A. So 2 to 3, 1 to 4, 2 to 1. Okay, so 3 to 2, 4 to 4. So now only you should have been known. So you have 2 to 3 and 2 to 1. So this is not a function. Okay, straight away it should be very catchy. Next we can have again 1 2 3 4 and 1 2 3 4. So 3 1, 4 2, 1 to 1. Okay, so is this a function? No, this is not. Why? Because 2 does not have an image. Okay, so this is fine. 1 to 1 and 3 to 1 is absolutely fine. Doesn't give a problem, but 2 does not have an image, so not a function. Okay, so next start with the third one. 1 2 3 4, 1 2 3 4. Okay, so 2 to 1, 3 to 4. So I want to caution you that in examination, after writing this diagram, so you have to write in words why you are rejecting that it is not a function, or why you are accepting that this relation is a function. You have to write it in a sentence as a conclusion, so that has marks. 1 comma 4, 2 comma 1, we have 2 times it is repeated. That's absolutely fine. So it is a set and it is equal to saying 2 comma 1 only once. Okay, so 4 comma 4. Now is it a function? Yes. Why it is a function? Why don't we have any We don't any have any problem. So 1, 2, 3, 4 all have very unique images. Also 1, 4, 3, 4, 4, 4 is not a problem because the image can have multiple pre-image. That's not a problem, and all pre-images are mapped to some of the images. Even 2 and 3, if they don't have pre-images, that's fine, that's also acceptable. So this is a function. So the first thing what we are seeing is 1, 2, 3, 4 all are mapped, and they are all mapped uniquely. Okay, so that's why this one is a function, this relation is a function. So let a equal to 0 plus or minus 1 plus or minus 2 and 3. Consider the functions a to r defined by f of x equal to x cube minus 2x square plus 3x plus 1 for all the element x, all the elements of a. Find the range of f. So by definition, what is range of f? Apply the function to every element of a, and whatever result you get, make a set out of it, and that will be the range of f. Okay, so what we have to do, we have to find out what is f of 0, f of 1 minus 1, or f of 2 minus 2, and f of 3. So that will be our first requirement. Okay, so let's do that one. uh, F of 0, so x cube 2x square, it will be 1. Okay, x cube 0, 2x square again 0, 3x again 0. 1 does not have an x term, that's why 0 will not be multiplied, that's why we will be having 1. So for those who didn't understand, we will just uh, have a lengthy way. Okay, so next one, f of minus 1. Okay, so we'll take plus first. Okay, so x cube remains x cube, 1 cube minus 2 1 square plus 3 multiplied by 1. Okay, plus 1, so that should be 3. Okay, so what do we have here? Minus 2 we have 4 5 minus 2. Okay, so uh, we'll just 5 minus 2, 3, 5 1 3 1 5 minus 2 3. Okay, so make it a minus 1 now. Let's see, minus 1 cube plus 2 into minus 1 square, not minus. Okay, so plus 3 into minus 1 plus 1. So what do we get here? Minus 1 cube, 1 cube remains minus 1. Okay, so this minus 2x square, this remains minus 1 square is 1, so minus 2 plus sorry, minus 3 plus 1. Okay, so what do we have here? So plus 1. Okay, so this plus 1 minus 1 cancels, and minus 2 minus 3 is a minus 5. Okay, so next one we'll continue. F of plus 2. Okay, so 2 cube minus 2 into square plus 3 into 2 plus 1. What do we get? F of plus 2, it is 7. F of minus 2 cube minus 2 square plus 3 into minus 2 plus 1, so that will be minus 21. F of 3, so 3 cube minus 2 3 square plus 3 into 3 plus 1, so that would be 19. So we have calculated for every element of a what is f of 0 plus 1 minus 1 plus 2 minus 2 and 3. So how do we represent what the result we have got? So f of a equal to f of 0, f of plus 1, f of minus 1. Okay, so f of plus 2, f of minus 2, so what is that? Minus 21, and the f of 3. Okay, so this is the range. Okay, so the range f of a is called range. This is okay, so this is nothing but range. So this is about fourth question. So in the fifth problem, so we have to see determine the images of the following subsets of R. Okay, so determine the images of the following subsets of R. So you have to determine the images, means that you should apply x square plus 1, and also find its range, because it's called images of the following subsets of R. So they are given as a subset, you have to write the images. So that also shows this also says that you have first you have to calculate what is f. Okay, so along with that you have to calculate the range also. Okay, so let a function f from real number to real numbers, okay, be defined by f of x equal to x square plus 1. Determine the images of the following subsets of R. Okay, so we have to determine the images. So let's do it. We will have, so 2 and 3 we have, it's called a1, and it's also some real number. Let's take R only. Okay, so it's a real number to real number, right? So what is f of 2? 2 square plus 1, and that should be 5. And what is the f of 3? It is 3 square plus 1, that should be 10. And this is how, so we can write f of a1, what we got, it will be 5 or 10. So this is how you can represent the range. So I'm giving something extra. Okay, so just for your information. And also we can write f equal to 2 comma 5, 3 comma 10, 3 comma 10. So this is also valid. Okay, so this is also how you can represent the what a result you got, and also you can represent like this. Okay, so these are the two representations. Write both the representation, so it will impress the evaluator, so that you know the answer properly. So second question we will go on to, so minus 2, 0, 3, we all know the answer. So minus 2 whole square plus 1. Okay, so you get same answer. 0, so that will be 0 square plus 1, 1. And f of 3, again we know that 3 square equal to 9 plus 1 is 10. Okay, so 5, 1 and 10 we are getting. Okay, so how can we write a f equal to minus 2 comma 5, 0 comma 1, 3 comma 10. So this is also a way of representing our function. So here determine the images of the following subsets of R. Okay, so determine the images also they have asked for. So we'll write this one also, a2 equal to 5, 1, 10. Okay, so this is about the second question. We'll go on to third, a3 equal to see, observe here, it is in the bracket, not the flower bracket, normal bracket. That means that the variables, the elements of a3 are in the range of 0 and 1. So they are in the range of 0 and 1. How to write them? So how a3 represented, they can be represented. So a3 contains some real numbers such that they are between 0 and 1. Okay, they are between 0 and 1. This is how you can represent a3 as a set. Now if you apply function for that one, f of a3, so what can we have? So we can have represent like this. So it contains a f of x, okay, such that they are between, x is between 0 and 1. So you can write like this. So further you can write x square plus 1 such that it is between, x is between x and 1, not equal to 1. So this is how you can represent. Okay, so we don't have to calculate between, because between 0 and 1 x value you can write infinite real numbers, right, between 0 and 1. So if you represent this much, that's enough. So next one, we will have here square brackets. Square brackets also represent the same thing. Okay, so just like this bracket, square bracket also represent the same thing. So next A4. Okay, so A4, f of A4. So we need determine the images of the following as subsets of R. So they are asking for a range here. Okay, we have also given the functions also, images also calculated. So yeah, f of A4 equal to, so just like a previous, x is between -6 and 3. Okay, so you can represent this way. So it contains f of x such that it is between -6, x is between -6 and 3. Okay, so also you can substitute if you want x square plus 1 such that x is between 3 and -6. Okay, so this is the answer for the fourth one. Sixth question. So let A is equal to 1, 2, 3, 4, 5, 6, 6 equal, B equal to 6, 7, 8, 9, 10, and a function is from A to B. Is defined by f equal to, so these element ordered pairs. So determine f inverse of 6. So inverse means undoing the function. Okay, f of A equal to B, f inverse of B equal to f of A. So those who have forgot how it works, okay, so if you are mapping from, this is f of A, if you are mapping back, that will be f inverse of B. Okay, so this is how, this is f of A. You apply function to element A, you get B, and you apply inverse function and back you get A. So this is undoing the function you just applied. Okay, so f inverse of 6. So when there is inverse, we are looking at the image. Okay, so where is 6? 6 is here. Okay, so f inverse of 6 is 4. F of 4 equal to 6, f inverse of 6 equal to 4. That's how this works. Okay, f of 4 equal to 6, f inverse of 6 equal to 4. So f inverse of 9 we have, so we have two of the elements here. Okay, so we will have 5 and 6. Okay, so this will be about inverse. Okay, so f inverse of 6 is 4, f inverse of 9 is 5 and 6. So let's take a subset B1 and see what f inverse of B1 is. So 7 and 8, you have two elements. Okay, so see in the second position, 7 here and 7 here, 1 comma 2. Okay, f of 1 equal to 7, f of 2 equal to 7, or f inverse of 7 equal to 2, f inverse of 7 equal to 1. Okay, so next 8, you have 8 only one ordered pair, so its inverse comes to 3. So f inverse of B1 equal to 1, 2 and 3. So similarly, let's see it for B2 also. F inverse of B2. So what do we get? 8 here. 8 inverse is 3. 9 we have, so 5 and 6. And 10, so we don't have anywhere, it's we don't have any inverse for that, so we stop here for 3, 5 and 6. So this will be answer for f inverse of 6, f inverse of 9, f inverse of a subset B1, and f inverse of subset B2. Next one. So if function is from real numbers to real number, f of x is if it is greater than 0, then 3x minus 5. If it is equal to 0 or less than 0, it is minus 3x plus 1. Okay, so f of 0, so 3 into it is minus 3 into 0 plus 1. If it is equal to 0, minus 3x plus 1, so that's equal to 1. That's f of 0. F of minus 1, here again minus 1 into minus 3 plus 1 minus plus equal to, that becomes now 4. F of 5 by 3, so it's a positive, x is greater than 0, so we can use 3x minus 5, 3 into 5 by 3 minus 5 minus 5, it is 0, and also minus 5 by 3. Okay, so f of minus 5 by 3, it's a negative number. Okay, so minus plus. Okay, so we have cancelled this. 5 plus 1 is 6. Okay, so here one minus is there, here another minus is there, that becomes plus. 3 cancels, plus 1, so we have 6. So this will be about the first task. So let's see the inverse task we have. So f inverse of 0, how to find out, and we don't know whether to apply 3x minus 5, or we got this, or we got 0 by applying minus 3x plus 1. We don't know that. Okay, so we have to substitute, use both the formulas and see which one suits. So f inverse of 0 came, okay, so for equal to x, f of x equal to 0. Okay, so we know the image, we don't know the pre-image. So pre-image is some x. Okay, so we applied that function to x and got 0. Okay, so we applied function to some element x and we got the answer 0. F of x equal to 0. Okay, so this x, whether it is a positive number, whether it is a negative number, we don't know. So whether it is 3x minus 5 equal to 0, so by that we got 0, or minus 3x plus 1, by applying that we got 0, we do not know. Okay, so we have to apply both and see which one properly suits. Okay, so let's do it for 3x minus 5 equal to 0, x equal to 5 by 3. Okay, so next minus 3x plus 1 equal to 0, x equal to, so minus 1 by minus 3, 1 by 3. Now, so we know that in this case it is 5 by 3, in this case it is 1 by 3. So if you have x equal to 5 by 3, see, observe the formula here. So whichever number, x number which is greater than 0, 3x minus 5 we apply. So if x equal to 5 by 3, applying 3x minus 5 is a correct idea. Okay, so correct formula. Now see here, x equal to 1 by 3. Now to apply minus 3x plus 1, x has to be 0 or less than 0, but we have got the answer here as 1 by 3. So this is a wrong application. Okay, this is a wrong application. This does not suit. So 5 by 3 is the most suitable answer. We will do another problems and you will get a proper idea. So f inverse of 0, that x is 5 by 3. Okay, so we initially we took as x, that x value is 5 by 3. Okay, so we will take another one now. F inverse of 1. So f inverse of 1, by applying so f inverse, if you take here, it becomes f of x, right? Okay, so by applying to some x, we got answer 1. So we will see which one. 3x minus 5 equal to 1. Is it that? So we'll see. X will be equal to 6 by 3, that will be 2. Okay, so like next 3x plus 1 equal to 1. uh, X will be equal to 0. Okay, so now if we observe, so x equal to 2 also, if it is x equal to 2, okay, so then it is a greater than 0 number, and 3x minus 5 application is correct. Okay, next x equal to 0 if we take, so x equal to 0 or less than 0, minus 3x plus 1 application is correct. Okay, so if x, so x is a value, has a valid value for at 0 and also at 2. Okay, so f inverse of 1 is 2 comma 0. Okay, so for both the values, both the formula, we have valid numbers. How it is working, how we are talking, so I will do here only. Okay, so 2 0, here it is 1. So this is the how the function is. Okay, this is how the function is. So one can be has a pre-image in 2, one has a pre-image in 0 also. So next we will take f inverse of 3, f inverse of 3, f inverse of 3. So in some x it is f of x equal to 3. So we'll take 3x minus 5 equal to 3. So how can we do? Plus 8 by 3. So this is okay. So next let's see for minus 3x plus 1 equal to 3. 2 minus x equal to, so 3 minus 1 2, 2 by 3, it is minus here. So both are okay. So here x needed to be positive, 3x minus 5 valid answer. So here x needed to be 0 or less than 0, minus 2 by 3 valid answer. So f inverse of 3 equal to 8 by 3 and minus 2 by 3. Okay, so this will be the answer for f inverse of 3. Next, f inverse of minus 3 we have. So f inverse of minus 3 equal to x, x equal f of x equal to minus 3. So 3x minus 5 equal to minus 3. So x equal to plus 5, 2 by 3. So this should be a correct answer, not a problem here. Okay, so minus 3 x plus 1 equal to minus 3, x equal to minus 4 by minus 3. Okay, that will be 4 by 3. So this is a positive number. Now this is not suitable because 2 by 3 is a positive number and 3x minus 5 is a valid valid formula for x greater than 0. 4 by 3 is a positive number, and minus 3x plus 1 is invalid because x need to be 0 or less than 0. So this is invalid number we have got, this is a valid number we have got. So f inverse of minus 3 equal to 2 by 3. So this will be the answer. So again f inverse of minus 6 we have got question. So f inverse of minus 6, f inverse of minus 6 equal to so let's check equal to x, f of x equal to minus 6. Okay, so 3x minus 5 equal to minus 6, x equal to minus 1 by 3. So actually this is a wrong value for x, because x need to be positive. And also let's start with minus 3x plus 1 equal to minus 6, minus x equal to, so minus 7 by minus 7 by minus 3, that will be 7 by 3. Again, this is a positive number and not suitable for not suitable value for x in minus 3x plus 1. So this is also a wrong answer, not wrong answer, wrong value for x. Okay, so not a suitable value for x. So we are not able to find the value of x in either 3x minus 5 or minus 3x plus 1. Suitable value is not able, we are not able to find. So f inverse of minus 6 is null. Okay, f inverse of minus 6 is null. So what it is representing, it does not have a pre-image. Okay, so we know that so this map like this, and some of the value, for example minus 6, it does not have a pre-image. Okay, so here many values are there, they are mapped to many values here. One minus 6 is there and it does not have a pre-image. In function, a image may not have a pre-image, that's completely valid. Okay, so this is how it's working in functions. If you did not understand the last one, that's okay. So it's only for those who like to learn little deeper. Okay, so we'll go to the third one. Third one, f inverse of within square bracket minus 5 comma 5. We know that within square bracket means it is representing the range minus 5 to 5. So we'll start doing f inverse of minus 5 to 5. So it is representing the range of the value. So equal to x, f of x equal to minus 5 to 5. How can we write that one? So f of x varies from minus 5 to 5. Okay, so what is f of x? F of x can be, so it may be 3x minus 5, it may be minus 3x plus 1. So we'll substitute both 1 minus 5 less or minus 3x minus 5. Okay, now so we have minus 5 here. So when we had only like left hand side and right hand side, so we just took it here, right? So now we have two extremes. So if we are taking out minus 5, we have to take it on both sides. So how this will become minus 5 plus 5. Okay, 3x 5 plus 5. So okay, this 5 will go here also and here also. Okay, so what we are getting now, so minus 5 plus 5 is a 0, 3x 10. Okay, this x here also 3 is there, right? Still, so 0 by 3, 10 by 3. So 0 by 3 is 0, 10 by 3. If the image is between minus 5 and 5, if we assume that x is a positive integer, then positive real number greater than 0, then it varies from 0 to 10 by 3. So still we have not got the answer, so keep this thing in mind. Okay, so 10 by 3 is our interest. So let's go to next one. We have minus 3x plus 1 still. Okay, so f of x is between minus 5 and 5. So minus 5 minus 3x plus 1. Okay, so then what can we do here? Minus 5 minus 5 minus 1 minus 3x 5 minus 1. So minus 6 minus 3x, 5 minus 1 is 4. Okay, so take 3 here. Okay, so it is between 6 by 3 minus 6 by minus 3 x 4 by minus 3. Okay, so next what can we do here? So what do we do? Now 2 minus 4 by 3. So now x is greater than 2 but less than minus 4 by 3. This doesn't make any sense, right? Okay, so we have got this answer for the second equation, but it doesn't make any sense. Okay, so we are just changing signs here. Okay, we are changing signs here to minus 4 by 3. So when we did like this, so what do we get? We get minus 4 minus 3 as the least value. Okay, so the least value possible for x is minus 4 by 3. So to make a meaning out of this, we are changing this side, but our real interest is a minus 4 by 3 because that's the least possible value for x. Okay, that's the least value possible of x possible for x. We need to find the range for x, so we are just interested in range and not exact values. So remember that previously also when we checked for both the formulas, one of them occasionally got an invalid x value which was not suitable, right? Similarly we have got an invalid x value, but so we are interested only in range and not in the exact value of x. So we are interested in the least value and the highest value because the image moved from minus 5 to 5. So we want how does pre-image move from the least value and the maximum value. So the least value is minus 4 by 3. Remember in the previous formula the maximum value was 10 by 3. So it should have moved between 0 to 10 by 3. So the least value is minus 4 by 3, maximum value is 10 by 3. So how can we write now? So f inverse of minus 5 is least value is minus 4 by 3. So not a flower bracket, these are not exact values, they are ranges we are given. So square bracket 10 by 3. So least minus 4 by 3 value to 10 by 3 value, these pre-images value move. So similarly minus 1 do the same idea. Okay, so I will do f inverse of 6 and 5. Do the same problem, same steps, and you will be getting again the same value. Okay, so incidental, you are getting the same value. So this will be the answer you will get. Follow the same steps. Okay, so this will be just an introduction to how functions work. So next video we will talk about types of functions again, which we are very familiar with, one-to-one function, auto function, one-to-one correspondence, and so on. So those things we will see, and this is the end of the video for now.